Hi and good day everyone. Welcome to Halsey How To channel, where I share real project experiences for better skills that will lead to a higher pay career. Today, I would like to share with you how to avoid common pumping system design errors, part 3 of 4. When we design a pumping system, we always want to ensure that the operation of the pumping system shall run efficiently and without any problem. There are many common design errors one can make in the pumping system. Not knowingly, these can cause significant operational problems or inefficiency to the system. I have divided this topic into a few parts as below, and this is part 3 of 4. Part 1 of 4. The common errors made on pipe and fittings, such as fitting, butterfly valve and non-return valve installation orientation. Part 2 of 4. The common errors made on pipes' straight length requirements for equipment such as pump, non-return valve and flow meter. Part 3 of 4. The common errors made on suction sump design, such as minimum submergence, turbulence and water levels. Part 4 of 4. The common errors made on pipe velocity. I hope these videos will give you some insight in designing a pumping system to avoid those common errors and learn something new at the end of the videos. Please subscribe and like my channel before we go further. In this part 3 session, we will touch on the common errors on the suction sump design, such as minimum submergence, turbulence and water levels. Pump draws water from the tank through a suction pipe at the tank. The suction pipe can be either facing upward, downward or horizontally. However, with any suction pipe arrangement, the design of the suction pipe and sump is very crucial. A good engineering of suction pipe and sump design will not only allow for a smooth operation and efficiency of the pump, it will also reduce construction costs, as the tank capacity can be reduced. The common errors made by the designers is without considering the minimum submergence requirements. The minimum submergence is the minimum water depth or level above the suction pipe. The minimum submergence is required to avoid any air vortices and air entrapment into the pipe. The air entered into the pipe and pump will cause cavitation and vibration and subsequently damage the pump. In addition, minimum clearance is required from the tank floor to allow efficient flow entry to the pipe to avoid any excessive turbulence. To avoid these mistakes, the Hydraulic Institute guidelines shall be followed carefully, with the minimum submergence requirements of 1.5 d depending on the suction pipe arrangement. D is referred to the bellmouth outer diameter. If it is a horizontal suction pipe, the 1.5 d is measured from the center line of the pipe to the tank minimum water level. For a downward suction pipe, the 1.5 d is measured from the bellmouth entry or lowest level to the tank minimum water level. To avoid the huge volume of unused water or dead zone below this minimum water level, a suction sump is normally provided with a lower floor level. This will ensure no air is drawn or entrapped. To provide a smooth flow of water into the pipe, the Hydraulic Institute guidelines also recommended a minimum 0.5 d clearance from the tank floor. This will solve the blockage or choking of flow. That's all for today's session. I am happy to answer any comments if you have any doubt on the video. Please continue to watch part 4 or other parts of the series. Please don't forget to click the subscribe button and like my channel. Thanks for watching.